Do you ever wonder about living in space? Well, I do. A lot. At any given time, there are 3 to 6 people living in space right now. On the International Space Station, astronauts conduct research experiments and educational tasks to help us understand the environment in space a little better. In my opinion, the number of people living in space right now should be significantly higher. There should be 60 or 600 people living and working in space. In this video, we are going to take a look at the challenges preventing us from having that many people orbiting around us every day. The idea of people living and playing in space might not be as far out as you think. Let's start by quantifying the amount of resources we need to sustain one astronaut for one day. What are some things that you need to survive every day? Well, you wouldn't make it long without water. You need water to drink, sure, but think about how much water you use throughout the day. Many people take a shower, brush their teeth, wash their hands after the bathroom, flush the toilet, and of course, drink water. Some estimates suggest that the average person uses 300 liters of water per day. This value is astonishing to me. That is an enormous amount of water. Thankfully, astronauts on the space station use less, only about 10 liters of water every day, which equals 10 kilograms. With that said, if you were living in space, you might have to sacrifice showers, which is probably a deal breaker for some. In my calculations, I am going to add some extra water for various things that average people might need water for. Let's use 20 liters, or 20 kilograms of water per day per person. Next is, of course, food. Food is not only a source of sustenance for humans, food actually influences our happiness. If you eat bland food, your morale would be lower than if you eat some of your favorite meals every once in a while. One source I found suggests that astronauts consume under 1 kilogram of food every day. However, on planet Earth, the average human in modern countries devours up to 5 kilograms of food. In space, we might need to make some more sacrifices with food, so I will raise the amount of food to 2 kilograms if we are trying to be efficient but stay happy. Now, for perhaps the most important necessity that we don't have to worry about on Earth much, oxygen, or more specifically, atmosphere. We commonly learn that we need oxygen to survive, but we can't breathe in pure oxygen gas. We need something close to the pressure and composition of the atmosphere around Earth's surface. One resource I found suggests humans require 550 liters of oxygen per day. We can't really lower this value. In fact, I believe we should raise it slightly to 600 liters per person, just to be safe. 600 liters corresponds to 0.6 cubic meters of atmosphere. Using the density of sea level air, we find that to be 0.735 kilograms of oxygen every day. Just as a reminder, we wouldn't ship air to space at a constant temperature and pressure. It would be converted to a higher pressure in order to pack more stuff into a smaller volume. With that said, once it gets to space, the passengers will still require a familiar 1 atmosphere pressure and the correct composition of the atmosphere. I like round numbers, so let's round up to 1 kilogram of air per day per person. This accounts for some extra oxygen requirements as people will be exercising, consuming more oxygen. Okay, so with those 3 essential ingredients to survive in space, we have come to a total of 23 kilograms per day per person. You can clearly see that this value is dominated by the mass of water. I have left out one important thing thus far, and I'm sure some people know about recycling water for reuse, and yes, I'm talking about drinking your pee. It sounds a lot worse than it is actually though. On the ISS, astronauts have to urinate. This dirty water is sent to a water purifier where it goes through the necessary processes to be safe to drink once again. Another module collects humidity from the atmosphere, pulls some water out of it for reuse. The numbers were a little difficult to find, but it appears as though 97% of water actually comes from recycled sources on the International Space Station. We can also recycle oxygen. As we breathe, we release carbon dioxide, which could also be converted back to oxygen, but this value will be somewhat negligible, especially with all of my rounding. All of these things considered, our total mass per day can be roughly estimated at 5 kilograms per person. Excellent! Earlier in this video, I said we should have more people in space, right? I imagine a world where significant amounts of our population are not only taking flights to get to their job, but they are taking launches to get to their job in space. Imagine that. Honey, I'm off to work. Don't forget your helmet. I think we will be there one day. Currently, we have up to 6 people in space. If we suppose that our launch vehicle can carry 5,000 kilograms of resources to low Earth orbit, which is actually more than most launch providers are currently delivering, the crew would survive for about 80 days before another resupply mission is needed. That's a decent amount of time. Astronauts on the space station these days regularly go for several months without a resupply mission. I believe that water is the limiting factor in our numbers. Say there is a daily resupply mission, using 5,000 kilograms of resource mass again, and 5 kilograms per day per crew member. That could support 1,000 people to live and work in space constantly. That is pretty significant if you ask me. I know we live in a world with billions of people, but the number of people in space should grow exponentially once we get started. A daily resupply seems ambitious, but there are over 100,000 airplane flights every day on average. There was a time when that seemed impossible. Perhaps one day, daily resupply missions will be the norm. That is only possible if the launch cost is reduced. SpaceX launches rockets for about $62 million per launch. For an entire year of daily launches, that comes out to over $22 billion, which is greater than NASA's yearly budget. That number has to go down dramatically for it to be sustainable. Just for your reference, $746 billion, that's billion with a B, are spent yearly on airline travel. That's roughly $20,000 per flight. As launch prices come down and payload masses increase, I think this dream I have could become a reality in the near future. The numbers may seem bleak, but prices will drop. The first commercial flight in 1914 cost $10,000 of today's dollars for just a 23-minute flight. That is quite expensive, and that same flight might be just $100 today. Prices for airline tickets are 1/100th of their price back then. Another viable option to reduce launch mass is space farming. Yes, astronauts have grown edible food on the International Space Station already, although it has been proving somewhat difficult. But we know it is possible. More research will lead us closer to the optimal solution. Growing food in space may be a flourishing industry one day. I mean, who doesn't want a space salad or space fruit? That would reduce the frequency of resupply missions required. We could also improve the efforts to recycle and generate water in space. This would result in significant cuts to launch requirements. Again, the more we think about solutions to this problem, the closer we will be. But the story doesn't end here. There's one critical topic I haven't touched yet: gravity. Most of the time we forget about gravity. We just assume it's something is dropped and it eventually will hit the ground. But gravity may be essential for humanity's long-term survival in space. Bone loss is one of the most significant issues for astronauts in space today. As bone density decreases, more complications can arise that do not bode well for the long-term survival of humans in space. And who knows if a baby can be born in microgravity. Either way, I think we need some way to simulate gravity in space. This video is already pretty long, so I will wait to rotate into spinning space stations on you until another video. For now, I would like you to realize that in order to live in space, we may need a constant supply of resources from the surface of Earth. Or we can have space farms. Realistically, a combination of the two will be seen eventually. As a quick summary, the current challenges we face are launch mass, launch frequency, and lack of gravity. I plan on making more videos surrounding this topic because it is important to me and, quite frankly, consumes my thoughts. There should be more people in space. So go talk about this with others. Next time you're hanging out with your friends, bring up the topic of living and surviving in space. See if they have anything else to add, and if you learned something from this video, share it with them. We have to talk about this topic if we hope to ever make it a reality, and I know I do. Thank you so much for watching. Please add to the discussion in the comments below. I always look forward to your input. Would you like to see a video on rotating space stations? And is there anything I missed in this video? But for now, as always, be curious.